Question 12, we have the diagram shows a curve shape ABC. A to B is this curve. It's not a circle. B to C is this curve. And C to A or A to C. C is the center of the circular arc from A to B. Same with A and B. And we have an equilateral triangle. And we're using a compass on a straight edge to construct one. There's a few of them. The axis of symmetry. So if we imagine a line straight down, that will be an axis of symmetry. So how do we get the midpoint here of this line, or any of the lines in fact? So I'll try and get this midpoint here. So we put the point of the compass on B, and you draw your arc here and here. Then you put the point of the compass on A, you draw your arc here and here, and wherever they cross those lines, if we join them together, we should get the middle of this line here. So now the middle of that line, we can use a ruler from C and just draw the axes of symmetry through the midpoint of the other side. So you could do it for any of the vertices. That's the start of question 12. That's to write down the sides of the angle ACB when we were told it was equilateral. So ACB, they're all going to be 60, aren't they? And the length of the straight line segment BC is 40. BC is 40, okay. Find the length of the circular arc from B to C. So the circular arc from here to here. So we have a 40. So if we had a radius. So if we imagine C is the center of this arc. So this is a radius. C is the center, A is a radius. So it means that we actually have a circle going around like this. So there'll be another radius here. So the length of the arc, let's have a look at this diagram just a bit cleaner. So if we take just this part of the diagram, you can see here that this arc from B to C is inside a segment of a circle, and this, they're all 60 degrees, and if BC is 40, so is AB. So we have a radius here. A reaches out to B. This will all be 40 from A. At C, we're still 40 from A. So we have 2 pi r for an arc of a circle. So we're going to have to divide this one by 6 to get a sixth of it. So we have 2 by pi by the radius, which is 40, divided by 6 will be the length of this arc all the way along here. I'm typing this into a calculator. I'm using 3.14 for pi. It's giving me an arc of 41.86, which does make sense based on our 40. Correct to 2 decimal places. Let me just see, does it make a difference if I take the symbol pi? Taking the symbol pi, it gives me 41.887. So it does make a difference, 41.89. It doesn't tell you which one to use, so take the pi symbol, and that's it, correct to 2 decimals. Question 13 here, we have a picture of a goat and a climber, and the company's making a large poster based on this. The top section will be square, so the square has to be x by x if the bottom is x along here. So we have x. So we have x squared for the poster. The area, the total height of the poster is x plus 0.5. The 0.5 down the bottom from here to here. And the total area of the poster is 50 meters squared. Show that this is true. Well, the total area of the poster is going to be x squared plus this guy by this guy, 0.5 by x. And if that's equal to 50, we need to multiply by 2 to get 2x squared plus x. And 50 by 2 will be 100, and if we bring it across, minus 100 is equal to 0. So just write down that you've multiplied it by 2. Solve this equation. Near centimeter looks like the quadratic formula. So we have minus b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to get, if you write down b is equal to 1, the number in front of x, a is equal to 2, C is equal to minus 100. We'll type this into our calculators. Minus B, we'll just use plus. Then we'll change it to minus in the middle. B squared minus 4 by A by C, all divided by 2A, 2 times 2. So we're going to get minus 1 plus the square root of 8 by 100, 801, 801 divided by 4. And the other one will give us a minus value, so that won't work. So let's work out what this is. On the calculator, it's giving me 6.825, which is equal to 7 centimeters to the nearest centimeter. No, it says meters. This is 6.825 meters. So 682.5 centimeters, just be careful, which is 683 centimeters. In meters, correct to the nearest centimeter. So that's in meters. Forget about the 7. On to the next part. And the next part's number 14, the last part of the test. Part A, we're asked to work out the value of x, but it might help to read the question. So it's not the scale. We have CAB and DEC, both 90, which we can see here by these symbols. DEC, this one here. So we have similar triangles, it looks like, in this question. So if we write down, this is DEC, they just have them the wrong way around. Opposite the right angle is my hypotenuse, 15. X from E to C, 9 from here to here. Now this angle here at C is also in this big triangle, ABC. So if they both have a right angle and a same angle, then the third angle has to be the same. So we've got similar triangles. So from B to C is 2x. And here's my A, just label correctly. What else do we have? Well, we don't. We have 15 plus AD. So we're looking for the value of x. We have a y here too. We have, if we just put the point D on here, we have a 15 here as well, which is in the other triangle. So for x, we have Pythagoras in the first triangle. We have the diagonal as 15, so 15 squared minus 9 squared gives us x. So that's the square root of 144. That's going to work out to be an even 12. So now I can make 2x equal to 24. And on part B, I can use similar triangles to work out the value of y. So if we take the unknown first, y is right angled to circle. So right angle to circle in the other triangle is my 9. So 9 over. So 9 over, we also have this circle to dot. So that's what we have in the other triangle, circle to dot. So I'm going to use those two. So the sides are in proportion with these similar triangles. So 9 over 15 will be equal to right angle to circle, which is my y, over dot to circle, which is my 24. So 15y is equal to 9 by 24, 216. So y is equal to 216 over 15. So y is equal to 14.4.